Now we're going to be able to put rational numbers in order, and specifically we're going to look at fractions. But rational numbers really are any number that can be written like a fraction. Like 2 is a rational because you can put 2 over 1. 1/5 as a fraction, it's rational. 0.1 repeating, also seen with a bar notation, yeah, that's even a fraction. It would be 1/9. 0.2 is a decimal, can be a fraction, 2/10. And the square root of 16 is a fraction because the answer is 4, which could be 4 over 1. So if practically everything that we're familiar with are rational, what's the opposite? Irrational. Irrational are numbers that cannot be written as a fraction. Like what? Pi. Pi is irrational. It is 3.14159 ... It repeats forever without any chunk of numbers. Without any chunk of numbers repeating themselves. But the number itself is infinite. The decimals go on forever. Another irrational number would be the square root of anything that is not a perfect square. Solving for the square root of 15 would give us a decimal number with digits that are infinite and no chunk of numbers repeat. So which list of fractions shows them in order from greatest to least? One thing to notice here is that they all have the same fractions for A, B, C, and D. They're just in a different order. And one method that we could use are fraction bars. I kind of think of them like candy bars. And we're going to represent them, each fraction, on a fraction bar. So 9/10, I'm going to split this candy bar into 10 pieces. Here's 1/2 and 1/2, so I need 5 on each side. That would be 2, 3, 4. So I actually made 9 cuts. 9 cuts gives us 10 pieces. And I'm going to represent 9/10 by shading in 9 out of 10 of those pieces. So I divided the second one into fourths, and I'm going to shade in 3 out of the 4. The other one is in 12ths, shading in 7 out of 12. 2, 3, 4, 5, 6, 7. Okay, there's 7/12. And then 1/3. And now I can see that the largest fraction would have to be the 9/10, and then after that would be the 3/4. So the only one that can be is A. I also wanted just to show you that you could change them to have common denominators. So looking at the 3/4 and the 7/12, I'm going to take the denominator times 3, and so the numerator times 3, and then we can compare these two fractions here. So it just depends on what you like to do. Okay, pause the video and write these fractions in order from greatest to least, and try it out. Try out drawing fraction bars just so you can get a visual and understand what a fraction really is, and that it is part out of whole. So 5 out of 6. 5 out of 6 are shaded in. Okay, so here they have all been split up on fraction bars, and we can see that the greatest one shaded in is the 11/12. After that would be the 5/6, then 7/10, and then 1/5. And just so we can see this with common denominators, what about 11/12 and 5/6? They seem so close in size to each other. Well, we could write them with common denominators, and 5/6 we can change to something 12ths by multiplying both the numerator and the denominator by 2. And that would give us 10/12. Compare that to the 11/12, and 11/12 is going to be the greatest one. I also want to point out that, of course, there are more than one ways to solve math problems, and we could rename all of these fractions into decimals if you would rather do that. Remember, the numerator is divided by, the denominator, so we would have 5 divided by 6. And so I think you get the idea.